class, let us say something about the characteristics or features of catalysis. See, important characteristics which are mentioned in your textbook. First one is activity, second one selectivity, and shape selective catalysis. These three are important. Before going to discuss about these three, I would like to give some other important characteristics of catalysis. You know, catalyst. Catalyst is a substance which alters the rate of reaction without undergoing any change in its composition and mass. Now, one important property of catalyst is a recoverable substance. If you use a substance as catalyst in a reaction, after the reaction you can get back or recover that substance without change in its composition. That is important. Without change in its composition as well as mass. But there may be slight change in its physical properties. We'll give an example. In the preparation of oxygen by heating potassium chlorate, in this case, often we use manganese dioxide as catalyst. See, if you use manganese dioxide, crystalline manganese dioxide in this reaction as catalyst, after the reaction you will get manganese dioxide only without any change in its composition. And mass will be same. But crystalline manganese dioxide is converted into amorphous manganese dioxide after the reaction. Crystalline manganese dioxide used, but finally got amorphous manganese dioxide. So there may be slight physical change. This indicates during the catalytic reactions, catalyst also involved in the reaction, but at the end it is regenerated. That is one point. Next one is small amount of catalyst is sufficient to bring about a chemical reaction significantly, to change the rate of chemical reaction significantly. See, small amount of catalyst sufficient. If actually the combination of 2.5 liters of H2 and O2 to form H2O, hardly 1 milligram of finely powdered platinum is used to bring about the combination of 2.5 liters of hydrogen and oxygen to combine and form H2O. Amount of catalyst required is hardly 1 milligram, or 1 milligram of catalyst platinum is sufficient. Next property is activity of catalyst is maximum, highest at a particular temperature, and it varies from catalyst to catalyst. The temperature at which the activity of catalyst is maximum, highest, is known as optimum temperature, and it differs from catalyst to catalyst. For example, for nickel, optimum temperature is around 150 degrees Celsius. copper 200 to 250, platinum 450, so on and so forth. Next one is, in a reversible reaction, reversible reaction attains a state known as equilibrium state, where the rates of forward and backward reactions are same. In such reversible reactions, if you use a catalyst, what happens to the equilibrium state? It is important one. Catalysts do not alter or change the equilibrium state of reversible reaction. In fact, catalysts help to attain the equilibrium state more quickly by increasing the rates of forward and backward reactions equally. It is important characteristic of catalyst. Generally, catalysts do not start the reaction, but they accelerate the reactions which are very slow. Normally, catalysts are used to alter the reactions which are normally slow in rate. Next, catalysts are highly specific in nature. That is, one substance which acts as catalyst in one reaction need not act as catalyst in all other reactions. It is one. See, these are some characteristics of catalysts. Now, we shall see the activity of catalyst. What is activity of catalyst? It is the ability of catalyst to increase the rate of reaction is known as activity of catalyst. The ability of catalyst to increase the rate of reaction is known as its activity. The activity of catalyst generally depends upon the extent of chemisorption. During the catalytic reaction, the reactant molecules get adsorbed on the surface of catalyst. Adsorption of reactant molecules on a catalyst surface takes place. So, the activity of catalyst depends upon the extent of adsorption. Greater the rate of adsorption, particularly chemisorption, higher the rate of chemical adsorption or chemisorption, higher will be the rate of reaction. We know that rate of adsorption increases when surface area of adsorbent is more. If adsorbent provides larger surface area, more number of reactant molecules get adsorbed, they undergo reaction or interaction, then simply converted into products and detached from the surface. This is activity. Next one is selectivity of catalyst. Selectivity of catalyst is once again, it is the ability of the substance, that is catalyst, to direct the reaction to give the desired or expected products in short interval of time, that means with high rate and with high yield. The ability of catalyst to direct the reaction to give the desired products with high yield. In fact, I already told you, catalysts are highly specific in nature. If you use different substances as catalyst in one particular reaction or same reaction, you may get different products. If you use different substances as catalyst in same reaction, different products will be formed because each one direct the reaction in different directions so that different products may be formed. I'll give an example for this. Reaction between carbon monoxide and hydrogen. It is nothing but reduction of carbon monoxide. Say, in this reaction, if you use copper as catalyst, here these two react to form HCHO as product, that is formaldehyde, or you can say it is methanol. If you use copper as catalyst in this reaction, you will get formaldehyde. On the other hand, if you use nickel as catalyst in the same reaction, you will get methane and H2O as products. See, here copper directs this reaction, copper here acting as catalyst and directing the reaction to form formaldehyde. Here nickel acting as catalyst, directing the reaction to form methane. Similarly, if you use zinc oxide as catalyst along with Cr2O3 in the same reaction as catalyst and promoter, now the product will be neither formaldehyde nor methane. We will get entirely a different compound, that is methanol, methyl alcohol. This shows catalysts are highly specific in nature. If you use different substances as catalyst in a same reaction, different products may be formed because of directing in different directions. And give one simple illustration regarding this. Say, coffee use ಮಾಡ್ತೀರಾ. ಕಾಫಿ ಪ್ರಿಪೇರ್ ಮಾಡುವಾಗ ಶುಗರ್ ಯೂಸ್ ಮಾಡಿ ಆಸ್ ಸ್ವೀಟ್ನಿಂಗ್ ಏಜೆಂಟ್, ಆರ್ ಜಾಗರಿ ಯೂಸ್ ಮಾಡಿ, ಶುಗರ್ ಅಥವಾ ಬೆಲ್ಲ ಯೂಸ್ ಮಾಡಿ as sweetening agent. If you use sugar as sweetening agent, coffee will give one type of taste. On the other hand, if you use jaggery, bella use madadaga, you will get different taste. You just see, sugar and jaggery ಎರಡು extract ಮಾಡೋದು ಯಾವುದರಿಂದ? sugar cane ಇಂದಾನೆ. Both are produced from sugar cane only. Still, they give different taste to the coffee, just like different substances acting as catalyst in the same reaction. So this is about selectivity of catalysts. Next one, shape selective catalysis, which is important on the point of our examination also. See, the selectivity of catalyst, particularly in case of the substances zeolites used as catalyst in reaction, the selectivity of catalyst depends upon size and shape of reactants, products, as well as size and shape of pores of catalyst. The selectivity of catalyst in a reaction, particularly zeolite catalyzed reactions, the selectivity depends upon shape and size of reactants and products, as well as shape and size of pores of catalyst. See, it is observed particularly in the case of zeolite catalytic reactions. That is, reactions in which zeolites are used as catalyst. This one is known as shape selective catalysis. Zeolites are silicates, aluminum silicates. In silicates, actually silicates are made up of silicon and oxygen atom. They are bonded like this. There will be a type of network like this in silicates, SiO-Si. So in silicate, if of course to form zeolite, from silicate some silicon atoms are replaced by aluminium. So aluminium silicates, often known as zeolites. See, these zeolites have honeycomb like shape or network. Honeycomb network irathe zeolites. That's why they act as shape selective catalysis. Zeolites act as shape selective catalysis because they have honeycomb shape or structure or network. Okay. The generally used zeolite as shape selective catalyst is ZSM5. ZSM5, where it is zeolite sieve molecular porosity of 5. Zeolite sieve molecular porosity 5. See, this ZSM5 is used, generally used in petroleum industries, that is in the refining of petroleum, in the conversion of alcohol into gasoline. So this shape selective catalyst is used in refining of petroleum or petroleum industries and in the conversion of alcohol into gasoline. So this is about features or characteristics of catalysis. Next bit is enzyme catalysis. Enzyme catalysis. What are enzymes? Enzymes are a class of proteins present in all living organisms. That we know that. Enzymes are a type of catalyst, proteins present in all living organisms. They act as biochemical catalyst. They control some reaction, biological reaction taking or biological reactions taking place in our body. Now let us see the characteristics of enzyme catalysis. See, the mechanism of enzyme catalysis is like this. We just consider S, it is the reactant or substrate. This in the reaction combines with the enzyme used as catalyst. So here E stands for enzyme using as catalyst, S stands for substrate or reactant. Reactants first combine with enzyme to form an energy rich, that is activated complex or reaction intermediate, which is highly unstable. Next, this complex ES decompose to form the desired product P with the liberation of enzyme. This is the mechanism of enzyme catalytic reactions. See, important characteristics are, first one, enzyme catalysis is highly specific in nature. Enzyme catalyst is highly specific in nature. First point, important one. That means one enzyme acts as catalyst in one particular reaction only, and it will not act as catalyst in all other reactions. I will give one simple example for this. You know, conversion of molasses into ethyl alcohol. That is one of the method of synthesis of ethyl alcohol. See, molasses contain sucrose, that is C12H22O11. First, this hydrolyzes to form glucose and fructose. Okay. Say during the conversion of molasses into ethyl alcohol, first molasses is subjected to hydrolysis, and this reaction is catalyzed by making use of enzyme invertase. For the purpose, we use a substance known as yeast. Yeast contains an enzyme invertase which catalyzes the hydrolysis of sucrose into glucose and fructose. This invertase catalyzes only the conversion of sucrose that is present in molasses into glucose and fructose. In the next step, this glucose decompose to form ethyl alcohol and carbon dioxide. This reaction is catalyzed by an enzyme known as zymase. You just see, this enzyme zymase is also present in yeast. Here, this zymase does not catalyze this reaction, this hydrolytic reaction, whereas invertase does not catalyze this conversion of glucose into alcohol, because this invertase acts as catalyst only in this reaction. Okay. Similarly, in the conversion of maltose to alcohol, of course, to first glucose, then to alcohol. Here, in the conversion of maltose to glucose, an enzyme, of course, yeast is also used, where it contains an enzyme known as diastase, which converts maltose into glucose. Then that glucose is converted into alcohol by the catalyst zymase present in the yeast. So these few examples to show that the enzymes are highly specific in nature while acting as catalyst. Next one is, so first point is enzymes are highly specific in nature. Next point is the activity of enzyme is very high, maximum between the temperature 298 to 310 Kelvin, known as optimum temperature range. Between this temperature range, enzymes are highly active. Above 310 Kelvin or 40 degrees Celsius, enzymes lose their activities, normally undergoes coagulation. That is same. ನಮಗೆ ಡಾಕ್ಟ್ರುಗಳು ಹೇಳಿರ್ತಾರೆ, ಜ್ವರ ಬಂದಾಗ, ಜ್ವರ ಬರೋದು ಅಂದ್ರೇನು, ಟೆಂಪ್ರೇಚರ್, ಬಾಡಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆಗೋದು. ಜ್ವರ ಬಂದಾಗ ಡಾಕ್ಟ್ರ್ ಏನು ಹೇಳ್ತಾರೆ, ಹಾರ್ಡ್ ಫುಡ್ಸ್ ತಗೋಬೇಡಿ, ಲೈಟ್ ಫುಡ್ ತಗೊಳ್ಳಿ, ಹಾಲು ಕುಡೀರಿ, ಗಂಜಿ ಕುಡೀರಿ, ಈ ಥರ ಹೇಳ್ತಾರೆ. ಬ್ರೆಡ್ ಬಿಸ್ಕತ್ ತಿನ್ನಿ ಅಂತಾರೆ. ಯಾಕೆ? ಬಾಡಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆದಾಗ ಆ ಫುಡ್ ಡೈಜೆಸ್ಟ್ ಆಗೋದಕ್ಕೆ ಬೇಕಿರೋ ಎನ್ಸೈಮ್ ಆ್ಯಕ್ಟಿವಿಟಿ ಹೊರಟೋಗಿರುತ್ತೆ. ಓಕೆ, ಬಾಡಿ ಟೆಂಪ್ರೇಚರ್ 40 ಡಿಗ್ರಿ ಮೇಲೆ ಹೋಯಿತು ಅಂದರೆ 310 ಕೆಲ್ವಿನಿಂದ ಜಾಸ್ತಿ ಹೋಯಿತು ಅಂತ, ಆಗ ಆ್ಯಕ್ಟಿವಿಟಿ ಹೋಗ್ಬಿಟ್ಟಿರುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಅವಾಗ ಫುಡ್ಡು ಡೈಜೆಸ್ಟ್ ಆಗಲ್ಲ, ಅನದರ್ ಪ್ರಾಬ್ಲಮ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ. ಫಾರ್ ದಟ್ ರೀಸನ್ ಹಾಗೆ ಹೇಳಿರ್ತಾರೆ. ನೆಕ್ಸ್ಟ್, ದ ಆ್ಯಕ್ಟಿವಿಟಿ ಆಫ್ ಎನ್ಸೈಮ್ಸ್ ಇಟ್ಸ್ ವೆರಿ ಹೈ ಅಟ್ pH ranging from 5 to 7, particularly 5 to 7, 3 to 9 of course, but here between 5 to 7 activity is maximum. So this particular temperature activity of pH is very high. Next, in presence of some substances, activity of enzymes increases. Consequently, they are known as enzyme activators, something like promoters. Generally, the enzyme activators are sodium ions, copper ions, magnesium ions, potassium ions, etc. Another thing is, activity of enzyme decreases considerably in presence of some substances. They can be called as enzyme poisons. Enzyme poisons. Such substances actually block the functional groups present on the surface of enzyme. As the result, catalytic activity decreases. These are some important characteristics or features of enzyme catalysis. In fact, enzyme mechanism of enzyme catalysis is something like lock and key mechanism. Lock and key mechanism. ಕೀನ ನೀವು ಲಾಕ್ಗೆ ಹಾಕಿದಾಗ ಲಿವರ್ಸ್ಗೆ ಕೀ ಸೇರುತ್ತೆ, ಲಾಕ್ ಓಪನ್ ಆಗುತ್ತೆ. ಹಾಗೆ in the enzyme catalysis, the reactant molecules fix to the functional groups present at the surface of enzyme and undergo change. So this about catalysis.